So, very good morning to all of you, dear students. Today, our topic is the reaction of aldehydes with base. Or in your syllabus, it has been mentioned that reaction of the compounds which contain alpha hydrogen. Alpha hydrogen. So, this reaction is called as aldol condensation. So, this will be the last reaction of aldehydes and ketones, where we were discussing the chemical properties. After that we will take the another topic, that is carboxylic acid. Okay. So actually aldol condensation means aldol means aldol condensation means actually there are two molecules of aldehydes gets condensed to form a new molecule which is having character of aldehyde as well as alcohol. So we will see here that what the product is. The product formed is actually the aldol. Clear? So here we will see here what actually happens. So in case of aldol condensation, the aldehydes are treated with a little solution of base. Clear? Aldehydes are and ketones, which the aldehydes are ketones. Only those aldehydes ketones which contain alpha hydrogen atom undergo self addition reaction. दिस इज कॉल्ड एज एल्डोल कंडेंसेशन रिएक्शन, जो मैंने ऑलरेडी तो मैं आप लोगों को बताई है. तो एक्चुअली देयर टू मॉलिक्यूल्स ऑफ एल्डिहाइड्स undergoes condensation, or any of the or two molecules of aldehydes or ketones containing alpha hydrogen undergoes self addition to give the aldol that's called as aldol condensation. Clear? The name aldol is referred to abbreviated as because it contains two functional groups. The product aldol formed here it has two functional groups, that is it is having the hydroxyl group as well as aldehyde group. Clear? So that's why the product formed which is contain both these groups, aldehyde group as well as alcohol group, the name indicated aldol is because of these things, that is it has both aldehyde as well as alcoholic group. Clear? Which is formed in the final product. Clear? As I have mentioned above. So let us see what actually happens. These are the two molecules of aldehydes. In presence of base they form the aldol, that is 3 hydroxybutanol. The IUPAC name you must I have already taught you how to write the IUPAC name of the compound. Just write the numbering first, select the longest chain, then give the numbering starts from the functional group which is more preferred, and among them there are two groups. One is OH and second is CHO, aldehyde group and alcoholic group. But in case of from the IUPAC nomenclature, rules of the nomenclature, CHO is having more preference than this aldehyde, as a result of which this CHO, and that means aldehyde, it acts as a main functional group, and this and it acts as a secondary suffix, and this alcoholic group which is having less preference as compared to this aldehyde, so it acts as a prefix. Clear? So write the name of the compound. How will you write the name? Just give the numbering from the main functional group, that is aldehyde. This is CHO here, so its first number gets from here, first, second, third and fourth. Clear? So write the name. First, we are from the IUPAC name we use first prefix plus word root plus primary suffix plus secondary suffix. Clear? Prefix means any of the substituent. To substituent, here we are in the molecule, the main functional group is aldehyde, and this alcoholic group is hydroxyl group is taken as substituent or prefix. So it is present at third position. So we'll write that 3 hydroxy, 3 hydroxy. Second thing, write the word root. Word root, how many carbon atoms are there in main chain? There are 4 carbon atoms, so you will write but. Clear? Second thing, you write the primary suffix. Primary suffix. So primary suffix is the connectivity of the carbon atoms, whether there is a carbon-carbon single bond or carbon-carbon double bond or carbon-carbon triple bond. So there is no carbon-carbon double bond, no carbon-carbon triple bond. There is only carbon-carbon single bond. You will write the primary suffix as N. Sorry, here it is not working. It is N. Clear? So here, after that you are write according from the IUPAC rule. The second last you write the secondary suffix. The secondary suffix is the main functional group, and secondary suffix of this aldehyde group is L. So after that you will see here the name of the compound is 3 hydroxy 3 hydroxy but 4 main chain carbon atoms, and here is actually N, but after that in secondary suffix is L. So being a vowel A is a vowel, E gets dropped. That is why you are writing this 3 hydroxybutanol. Clear? So this is IUPAC name of the final product, Aldol. So let us see actually how the reaction takes place. What is the mechanism of the reaction? In the setup, in first setup, I have already told you actually the aldehydes are treated with the base. So actually the reaction in the reaction mechanism, this base actually is a sodium hydroxide, and from sodium hydroxide you will get sodium positive and OH negative, and this is acts as a base, and this base abstracts the alpha hydrogen atom. So important thing here is that the molecule which contain alpha hydrogen, only those molecules which undergo which only those molecules undergoes uh, aldol condensation. Clear? So there here we see that this base will abstract the hydrogen from this methyl group, because this hydrogen is alpha hydrogen, because it is present at the alpha carbon. So first you should know what is alpha carbon. It is carbon here. Why it is called as alpha carbon? Sorry, it is carbon here. This attaches to this functional group, that is aldehyde group. So carbon which is adjacent to this carbonyl group, this is called as alpha carbon, and the hydrogen which is attached to this carbon is called as alpha hydrogen. So there are 3 alpha hydrogens actually present. Clear? So we we have we should, there at least there should be 1 alpha hydrogen. So here we will see there's a one there are 3, to one of them will be abstracted by this base. So here the base abstract one of the hydrogen atom here, results in the formation of results in the formation of sorry results in the formation of water. Clear? The base abstract the hydrogen atom here, forms the water, and the remaining here is a carbanion. This is a reactive intermediate, reaction intermediate, and it is very reactive. It is very reactive. Now it acts as a nucleophile because it is having lone pair of electrons present on this. So in the next step we will see. But the driving force behind the formation of this carbanion is resonance, because this carbanion is stabilized by resonance. So resonance you have already learned. It's more the resonating structures, more is the stability of the molecule. So this carbanion gets stabilized by this by resonating structures. The resonating structures of the carbanion are like this. So this negative charge, that is the lone pair of electron, unshared pair of electron, and comes in conjugation with this double bond because of the presence of more electronegative atom oxygen, as a result of which you will see the formation of 2 resonating structures here. Clear? So because of this resonance, this gets stabilized. So this is the driving force of the acidic character of this aldehyde. So this aldehyde molecule here acts as an acid. So acid is any substance which gives proton to the base. Base is here sodium hydroxide. From sodium hydroxide, we have taken OH negative as a base. So it abstracts the proton from the acid, from this weak acid. Clear? So this indicates, as already mentioned, this indicates alpha hydrogen atom is acidic in nature. So this alpha hydrogen atom, which was abstracted by this base, this this is acidic in nature. So this is acidic in nature. Clear? So this is the first step. In the first step, you have seen how this carbanion have been generated. So in the second step, what happens? The carbanion which have been generated in the first step acts as a nucleophile because it's electron rich center. So it will act as a nucleophile and it attacks this carbon atom, carbonyl carbon, because you know that I have already told you carbonyl carbon is polar. It contains some positive charge, it has having some negative charge. So this electron rich center will attack to this electron deficient center. So here is a attack of this, as a result of which the double bond gets shifted to this oxygen. Similarly, as a result, these two molecules get bonded. They form covalent bond, and the intermediate structure formed is here. Clear? In which the oxygen is having negative charge, and two molecules gets condensed. Condensed means they gets added. Clear? So that's why this is called as a condensation reaction. The condensation means two molecules gets condensed together. Clear? The intermediate molecule formed here. This intermediate molecule further in presence of water. In presence of water, in the reaction mixture there is all presence of water also. The water here is, I will write like this, hydrogen. This oxygen will abstract this hydrogen here, and remaining is OH negative, which is present in the solution, and this results in the when this abstract hydrogen from the water, this results in the formation of aldol, that is called as acid aldol. And this OH negative will combine with the sodium positive, which is already present in the solution formed in the first step. This again forms the sodium hydroxide. So base has been regenerated again. So this is the 3-hydroxybutanol. So this is how the condensation of two aldehyde molecules takes place and results in the formation of acid aldol, or we may shortly say aldol. So because it contains OH group as well as CHO group, that's why it is called as a aldol, and the reaction is called as aldol condensation. Hope you understand, but you must note here that acidic nature of alpha hydrogen is due to the presence of electron withdrawing group, that is carbonyl group. So let us see. Actually, I have already told that the acidic character of this alpha hydrogen, here I will write again this alpha hydrogen, right? This is alpha hydrogen 3 attached to this carbon group. Okay? So this alpha hydrogen is acidic. Acidic means acid is a substance which gives proton. So this molecule gives a proton. The why it is acidic? Why this is an acidic proton? Because the presence of electron withdrawing group. See, carbon is attached to this electron negative atom, as a result of which it gets shifted. So in order to compensate it, these electrons get shifted to here. So this is how, this is a driving force of this electron withdrawing groups. Electron withdrawing groups are those which withdraws the electron density from here. Actually what happens that this in the aldehyde molecule, this carbonyl group withdraws the electron density from this carbon atom to this oxygen atom, As a result, this is called the electron withdrawing group, and due to which this proton, because this hydrogen comes out in the solution in the form of H positive, which gets by abstracted by OH negative and result in the formation of water. So from this aldol condensation, you have seen that two molecules. Again, if you see here, actually the reaction in the aldol condensation reaction, two acid aldehyde molecules react together. They get condensed with the formation of water molecule, which is formed in the first step. So condensation takes place. There is a condensation, addition of the molecules takes place. As a result, the product form is called as aldol. So my question is to you: if I use this formaldehyde instead of acid aldehyde, if I use the formaldehyde, C CHO, this is a formaldehyde. Second molecule here, it is a formaldehyde. Two formaldehyde molecules are here used. So is there possibility of any formation of aldol or aldol, acid aldol, any of the aldol? Is there possibility of aldol condensation reaction? Pause the video and write down in the comment. So we will see here, in case of formaldehyde, so this is formaldehyde. Two molecules of formaldehyde are present here, but you must know, I have already mentioned here that only those molecules undergo aldol condensation where where there is a presence of alpha hydrogen atom. You will see, is there a presence of alpha hydrogen atom? I have already told you the carbon, the hydrogen which is adjacent to this carbonyl group, this carbonyl carbon. So there is no any of the carbon. First, there is no carbon. So this hydrogen is not alpha hydrogen. This hydrogen is not alpha hydrogen. So this is not also alpha hydrogen. This is not alpha hydrogen. So there is no possibility of any aldol condensation reaction. So hope you understand. So you must see the first whether the molecule is having any of the aldol, any of the alpha hydrogen. If there is a presence of any of the alpha hydrogen, then there is a possibility of aldol condensation. Clear? So the hope you understand. This was all about today's topic. Stay blessed. Have a nice day.